Hello, my name is Angel Masu and I'm going to talk about the hybridization of orbitals. I'm starting by explaining what are orbitals. Orbitals are zones or areas or volumes in which electrons are more likely to appear. For example, if we have an atom here, we can think that here would be like a sphere in the most simple case, like a sphere which determines like the zone in which electrons are more likely to appear. This is the structure that I am talking about. This is like the 2s, which means like that atoms electrons will spread throughout this zone. Now we continue with the next kind of orbital, which is the p1. For example, 2p. We can also use like the axis to make like a better understanding of this. For example, we have 2p, but these are moving in the x-axis right here. So we write 2px. We can also write 2py, meaning that the electrons will move in the y-axis, but with the p shape or form. Then we can also use the z-axis, and we can see here how is like the areas in which electrons are more likely to appear. Well, now we continue with hybrid orbitals and unhybrid orbitals. Hybrid orbitals are known as sigma orbitals, with the symbol of sigma, and these are like the strongest ones. And then they are like accompanied, or yes, when you have like a double bond or triple bond, the other bonds besides the first simple bond will be the p ones, the p bonds. So this means like the first sigma bond is like the strongest one, and the others that are next to it would be or would become the p bonds. And on hybrid are sigma bonds, which are the strongest ones, and these are formed from the overlap of atomic orbitals. And as I said, we can see here, for example, a single bond between two carbons forming a sigma bond, and then with two bonds we can have one sigma bond next to one p bond, and as well in the triple bond we will have one sigma bond and two p bonds. Now, what's next? I have here an image that shows, for example, if we have one s, that would be this sphere right here, and we have, for example, 3p, they will like combine the 4 and would be like there are 3 p's and 1 s, so there will be finally 4 sp3, and this way. And if we have 1s and 2p, they will become 3sp2, and as well 1 and 1 sp1, and that's it. Then some examples. For example, if we have like one carbon, there will be no hybrid orbitals. And for example, I will continue now with a carbon with 4 bonds. It would be like 4 single bonds, meaning that there will be 4 sigma bonds right here. We can see them right here. And in the electronic structure, there will be 4 sp3. And for example, if we already have in the first normal structure 2s2, and 2p2. In this new structure we will have 4 sp3, and the s will disappear, or well, we will see now 4 sp3 bonds. Then if we add or we change the structure for 3 single bonds, or well, 2 single bonds and 1 double bond, it will be 3 sigma bonds next to one p bond that will be this one, or well, this will be like p, not well, yes. And now we do the same with the triple bond. For example, right here, if we can see, we have the normal structure right here, in which we can have a triple bond next to a single bond. That means that we will have 2 normal bonds, which will be like the sigma bonds, and 2 p2 bonds. For example, in the electronic structure, we will see the electrons over the 2p2. I don't know how to say it. I am a little confused, or well, I don't know how to explain myself. And finally we have this structure in which we combine 2 carbons, and each carbon has its own bonds. For example, right here we will have in each carbon 3 single bonds, or well, 2 single bonds and 1 double bond. This will mean that we will have 3 sp3 bonds next to 1 2p2 bond, for example, and in the first carbon as well as in the second one. So when we combine this structure, we actually form, I just got confused in my last explanation. When we combine for example, one sp3 with another sp3, we actually form the sigma bond. And in this case, I've just confused words, and each single bond will be like an sp3. For example, in the first one, the carbon with the 4 single bonds will be sp3 bonds. Here, sp2 and 1 that will be like 2p, and finally in the last one, in the triple bond, we will have the 2p2 and 2 sp bonds. So now here we will have the 2 sp3 bonds forming finally a sigma bond, and the 2p2 bonds will form right here the p bond. So right here we will have the sigma bond, and these areas will be the p bonds, and this will be the other sp3 bonds. No, sp2. As we have right here 3, it will be 1s, 2p, so sp3, and these 2 sp3 form the sigma bond.